Hello, my name's Paul Szymanski. Previously, I had done a briefing on the SOAD, Space Operational Art and Design, which is the extension of the United States Joint Chiefs of Staff publications concerning on how do you fight wars on the ground or terrestrially, extended to space. Now I'm going to go into more detail of software I developed and tools to help you organize yourself when fighting space wars, to detect attacks, to determine adversary intent, and so forth. And that tool is called SWAT, the Space Warfare Analysis Tools, a whole set of different tools that's going to help you when you're trying to fight space wars based on foundational theory, doctrine, strategies, and tactics. So let me get to the next slide. So the purpose of SWAT, as I mentioned before, foundational space doctrine and automated battle management decision tools to help you fight and win the next space war. It's based on my 49 years experience developing all kinds of space warfare systems, analyses, program management. I've been on 12 different space weapons programs. I've worked on 5 different rendezvous and proximity operations programs, RPO, satellite inspectors, maintenance satellites, repair satellites, refueling satellites, whatever you want to call them. And though over my career, I had 86 different security clearances, all of those timed out 10 years ago when I retired. And so I'm only talking on class here. And when you really look at it, doctrine is always unclassified because you want the maximum number of people, your soldiers, sailors, Marines, Guardians, or whatever, to fully understand, how to fight wars. So what this software does, SWAT, it integrates space-related grand strategies, operational strategies, and tactics, and then linking those to terrestrial courses of action, because ultimately there's no colonies in space. The whole point of the U.S. Space Force and the militarization of space is to support military operations on Earth, not for their own right in space. So you really have to link up what you are doing in space to what is occurring on the ground, and you're supporting whatever operations are occurring and whatever the commander's intent is in terms of prosecuting the war and essentially winning it. And essentially, the goal is to look at more timely and comprehensive and realistic space battle management tools, techniques, thought processes, and so forth. And I like to say it normalizes the space warfare process. So it corresponds to terrestrial warfighting principles. When you really come down to it, whether it's ancient Greek warfare or futuristic space warfare, it's still human mind versus human mind. So a lot of the same principles apply. And if ultimately the commander who is directing what should be happening in space is really a terrestrial commander fighting the ground war, air war, naval conflict, whatever, you have to have similar thought processes and terminology and so forth when talking to him and understanding his needs. And so this is what I mean by normalization of doctrine, strategies, and tactics as they relate to terrestrial conflict. So how does SWAT work? Well, there's something called OODA loops: observe, orient, decide, and act. So you observe something on the battlefield, whether the ground or space. You sort of figure out what's happening. You orient yourself. You make a decision based on that, and then you have forces act certain ways. And so, if you had a copy of this briefing, you can click on these, and I'll show you the various techniques within SWAT that help support all 4 of these OODA loop steps. So SWAT has a whole list of potential space warfare threat intel indicators. It has actually all the orbital elements and a complete satellite catalog with characteristics embedded in it. It has radar and optical measurement data that inputs it into it and allows the user to detect or predict attacks happening in space. Part of the orientation is there's algorithms within SWAT that takes these intel indicators, radar, optical data, changing orbital elements, and comes up with algorithms to do what's called state change. For years, a satellite has acted a certain way, looked a certain way, and now it doesn't. Oh, one country, country A, suddenly has 20 of their space assets acting differently where they never have been before. Is that strategic warning? And then there's certain ways of looking at things happening in space. There are certain choke points. And so when you illustrate the space situation map, you have to be able to decide, well, are we coming under attack and have a way of doing it. And you don't do that with some 3D globe with 48,000 objects spinning around. No, you have to like simplify it into something that any commander can understand, whether a terrestrial commander or a space commander. And then there's also tools to detect what are the possible adversary courses of action in space being directed at you and what is their intent. And then this tool also helps you in the decision-making process of what to do about these adversary attacks against our assets. So it helps you develop space courses of action, and everything in SWAT is not a blank sheet. There's all kinds of proposed courses of action and indicators and things like that, so that you can pull down a list from them and work from there, or just to be, if nothing else, to give you an idea. And then there's also a target ranking tool, and then sometimes SWAT is called Shiva. That there's a different software actually called Shiva that looks at the flow of information on the battlefield from sensor to shooter. And it doesn't care that information is coming from space or from terrestrial resources like ground radars or drones or whatever. And it looks at all those various paths and the probability of each node will do its job and how long would it take. And you end up with a joint ranking tool for what are the prime targets you should go against to deny the information. And space is mostly information. It's generating imagery, signals intelligence, weather, navigational information, and transmitting that information over satellite systems. So if you're not really attacking space, you're not really attacking a satellite, you're attacking the information and you're trying to deny it or mess with it or something like that. So this target ranking tool, the Shiva target ranking tool, allows you to do that and optimize whether it's better to take out a satellite, a link from the satellite to the ground receiver station, the telecommunications coming out of it, and so forth. And then as part of the act, also includes, how do you respond to this threat? Visualization of space choke point maps, the satellite state changes illustrated on these maps, threat envelopes, kind of visualization of where are you most vulnerable and not. And then ultimately supporting all of these battle management, space battle management functionalities. You have Doctrine, space principles of war, centers of gravity, even definitions of how do you define space sectors of responsibility. And an excellent source of this is air defense doctrine, and this has been segmented, and what commanders in charge of what and what regions of space and so forth. So that definitions is very important. It was how you orient yourself for the rest of your operations. And then as far as space strategies go that, feed into the decision-making process for space warfare, it's very important to do space escalation control. And so there's a space escalation ladder linked to a terrestrial escalation ladder so that you try to figure out what level you're at, and you're trying not to increase the escalation in space and so forth. And you got to keep all of this in mind when you're trying to put together space courses of action. And then there's different space objectives, strategies, sequences, tempos, and all that help you formulate the best possible decisions. And many times you have a plan A, plan B, maybe even a plan C. And then there's specific tactics associated with this actions that you're taking in space. And there's lists of possible tactics. There's space reconnaissance contingencies lists to, try to figure out, okay, well, I'm taking this action. I got to verify that it actually happened. And do I have to attack again and so forth? So there's tools in there to optimize that. And then ultimately, there's a tool in SWAT for running a space working and generating theoretical space systems at the unclassified level and having all kinds of space indicators coming into the war game and sequencing and tools that allow players to generate courses of action and actual satellite orbital dynamics tools to figure out what is the best attack strategies and how long would each of them take. And it has structure to that with military standard messaging and so forth on that. So the state change is very important. How do you know if you're about to be attacked? Because with the SWAT tool, I've done analyses. One point I took 100 random space objects and said match the orbits of another 100 random space objects, no matter what the orbits and so forth. In other words, attack them. And so the SWAT software calculated all of that, and 96% of all those weapons met their target's orbital parameters within 24 hours. So really the space war is over with before you even know it, maybe before you even know you're under attack. So situational awareness is everything in space, and predictive battle space awareness, PBA, and all of these things are very important. So one of the critical tools of SWAT is something called SAW, Satellite Attack Warning. And I'll tell you a little bit about that. And that is, it looks at all 48,000 current catalog space objects, and it looks at their characteristics, radar cross section, optical cross section. Flashing is if a satellite is spinning and the sun hits one side and then doesn't, and all that, you see flashing going on. And some, at least in the older days, some satellites were spin stabilized. And if suddenly the flash period changes, that's interesting. What kind of stabilization is it? Is it spinning or three axis? And if that changes, that will show up in the SAW state change tool. What shape is it? Length, width, height, mass, spin rate, delta V, which is the amount of fuel estimated remaining and what it started with based on its mass. What's its actual position, let's say geosynchronous wise? It's no longer overhead, it started moving somewhere else. Onboard power, if you can get this information. What kind of signals? Now, it hasn't been inserted yet, but signals intelligence from the satellites can easily be inserted into the SWAT tool to say, well, for days and weeks and months, there's been kind of these signals and suddenly they're different. And all of these indicators are maybe minor in some sense, but all these little things add up to something big. So, for example, if a satellite is about to maneuver, which is unusual, change its orbit somewhere, it has to change attitude so that you see that somehow. It has to change attitude to have its reaction jets, pointed a certain way. It maybe has to fold in its solar panels so it has a different optical cross section. All these things add up to something being suspicious. So you look at the physical characteristics and the classical orbital characteristics. If it's change, altitude, inclination, eccentricity, all of this is of interest. So essentially what we're doing here is we have a 26-dimensional space of the state of the satellite. And let's just look at one slice of that. Let's say inclination. And you look at, well, it was advertised, an adversary advertised this satellite to be a weather satellite. And for years, it had a certain inclination. And here's the range of values for generally weather satellites, let's say. And here's a range of values of, let's say, something slightly different, a science satellite in green here, weather satellites in blue. And you have this unknown object or an object but suddenly starts changing. So essentially, the algorithm is actually very simple. It just says, well, how close am I to the state I'm supposed to be in? And if I start changing, how far away do I get from it? And all those values add up. And it's actually a remarkable algorithm. It's shown all kinds of strange things happening in space. Uh, Satellites starting to die before they're publicly announced, satellites maneuvering. Certain countries seem to have a different playbook, orbital dynamics book, and they send a satellite to graveyard orbit, yet its orbital elements improve with time instead of getting worse due to solar pressure and differential gravity gradients and all that. I mean, there's kind of suspicious things that are going on. So, for example, this is EchoStar, a communication satellite. And here's all the various factors, at least in the orbital regime, the orbital elements. And this is the correlation of the state change number. And the state change, it's, usually around 2 or 3 or 4, and that means nothing really has happened. It's a dimensionless number that comes out of the algorithm. But if it starts getting 6, 7, 8, 9, something really bad or different, let's say, is happening. So this is the dates, this is the state change number, and it's tooling along, and there's a certain statistical variability, errors in measurement and so forth. And suddenly, blip, something happened. And so you look at all of these things, the radar cross section changed, the altitude changed at the same time it went blip. You look at all these different factors and you see, yep, it looks like it did an orbital maneuver, especially with the first derivative of altitude and so forth. So what happens is, here's all the various factors, the visual magnitude, the radar cross section, the orbital elements, all of this is plotted here via date. And you can see this is the characteristics of the EchoStar. And yeah, there's random things happening again for, measurement errors or something. But suddenly, when it starts maneuvering, a lot of the parameters start changing, radically. And that's why even small changes sort of add up because, one change implies multiple other changes happening with the satellite system. So there's all kinds of strange behavior one can observe using the SWAT and SAW tools. Now, this is an example of one. This is looking at the Chinese Badao. It's their GPS navigational kind of satellite. And it's correlating how close it gets to the American GPS satellites. And even though they're in slightly different inclinations and more or less the same altitude, you can see that over time, over a 30-day period, just about all the Badao satellites, the ones in different color, get within 2,500 kilometers or even 250 kilometers of a GPS satellite. In other words, I'm just theorizing here, they could drop off space mines or do something, and so this is a possible threat, a long-term intel assessment, not necessarily a short-term one that SWAT does a lot of too. So here's an example of some of the correlations that happen. This is a screenshot of a SWAT screen. And what it is it's trying to figure out what is a possible adversary intent and actions. And so what you put in here is there's various intel indicators that are pulled on list here. And it says, well, there's major maneuvers, minor maneuvers. The anti-satellite forces appear to be lining up in a sequence. There's maintenance satellites and increasing interest from, ground controllers, all these sort of intel factors you put in there. And the SWAT software automatically calculates what is the most likely conflict level you happen to be in at the moment, ranked according to conflict level. What's the most likely strategy the adversary is implementing against you? And this is a theoretical assessment right now, but sweep the skies or hidden negate, and there's old definitions of what all those mean. And it gives the sort of the probability or the percentage of the indicators that are indicating that. And then not only the most likely strategy, but what is the most likely tactic uh, being implemented against you? So this is an interesting tool to, start trying to figure out what's happening in space. And the beauty of SWAT and SAW, satellite attack warning, is well, you got 48,000 objects up there. You can't really monitor them all. This software will tell you, well, here are the top 10 that changed in the last 24 hours. Task your intel sources and radars and optical sensors on the ground to concentrate on those 10 just to see if it's really true, so to speak. So that's a useful tool. Again, trying to generate indications and warning and what are the proper assessments and courses of action you should implement because of what's happened. So I'm going to go over some possible ways of looking at it because it's hard to visualize these 48,000 objects. There are strange things happening in space just due to the orbital dynamics. There seems to be a concentration on tactics in the current Space Force in the United States, not strategic. And so they have an attitude of, well, I have my satellite that's important to me, and then this adversary satellite's slowly coming close to me. Well, how do you define closeness? Now, I define closeness between two objects in space as the amount of delta V fuel and the amount of time it would take to match orbits. And according to that definition of closeness, a satellite on the opposite side of the Earth is close to you if it's in the same altitude and inclination, just a little bit of a phasing burn to come at you. So it's important to have visualization tools to summarize to you, what the situation in space is, and to summarize to people like an army general who might not even understand space, but who could understand a flat map and look at these things are coming at me. And I'll show you some of that. So here's some of the possible visualizations. This is within SAW, there's a 3D tool that shows you the various sensor cones, the various maneuver points, and the target that you're going against. That's rather complicated. Let me show you some other things. This is showing you that over a 30-day period, these are for different range boxes and how often through natural orbital maneuvers and motions, satellites get close to you. And you can't help that. It's freedom of navigation there. And so in different orbital regimes, there's many objects that get very close to you in the different range boxes of closeness. The other thing I wanted to emphasize too is that this is part of the normalization of space that is normalized to the ground. And so there's a MIL standard 2525 that's both in the United States and NATO doctrine. And they had about 5 different space icons, and that wasn't good enough. They didn't cover anywhere near the actual kinds of objects in space. So I invented 1,200 new ones to be able to put in situation maps, just like the Army has a situation map for the ground. And so, the blue is friendly, red is adversary, green is neutral, there's unknown, different shapes, colors, different symbols inside. This is geostationary orbital kinetic kill vehicle. This is a radar on the ground. This is debris in medium Earth orbit, and so forth. And that's important. I mean, you got to get the foundations right in order to, be in the right place 10, 20 years from now. So getting back to the doctrine and how we have to sort of show what's happening in space. And my assessment was what I call an AVIS map, altitude versus inclination survey, like the rent-a-car. And this is the altitude of space objects, and this is the inclination. And that sort of sets choke points or the two most important factors when it comes to maneuvering and location in space. And so this is showing you all the objects in the last calculation I did a while back. And you see flashing objects with square boxes around them. Those are the ones that had the biggest state change over the last 24 hours. And then I surmise certain space defense identification zones. This is, based on the air defense doctrine. And so you sort of have this blue zone of generally that's where rocket bodies and debris and satellites and all that are launched of some certain inclinations from, Vandenberg or from Kennedy and so forth, generally end up in. You see, it's mostly blue objects. You see the red objects, these are kind of the red zones. You've got the green zones or the neutral country objects. And so you can see it's just sort of segmenting out. Now, these lines are showing you, you can say, well, over the last 72 hours, tell me how things have changed. So over the last 72 hours, this object went up to geosynchronous. And so these lines are important. It means, yes, something maneuvered, something changed. And there's interesting things too that, okay, well, here's the blue zone. Now, what are these red objects doing in here? Maybe that's suspicious. I don't know. But they're called areas of responsibility, again, using classical terrestrial terminology. And then inside of, let's say, a space defense identification zone, it's what's called a long range engagement zone. And I can define those later, what they mean and the amount of distance and time it'll take before it meets you. So it's sort of a higher warning flag. And then there's a close attack engagement zone saying, yeah, we're really getting serious here, guys. These guys are coming in hot. So I've zoomed in, and when you zoom in, the appropriate space iconography shows up. And again, these are red, potentially adversary satellites. The green are allied satellites, or neutral, let's say. So this shows this is space debris. This is a rocket body symbol. Here's another rocket body. Here's an imagery satellite, a red one, monitor. I forget which country. Here's a debris, CZ, that's China. Here's more space debris. But what's interesting is this JB3C imagery satellite. And it's showing in sort of the squiggle lines and so forth. And that's showing over the last reporting period. This has changed its altitude slightly. Okay, that's just interesting, but it pops up at the screen at you immediately. Now, zooming in even more. Here's a Cosmos Russian 2421 satellite. And it was, I think it was an imagery satellite. I forget. I can't see that. And it has the flashing symbol on it saying, hey, something changed. And you can look here, the state change score is 9.9, very high. And what changed the most was the mass of the satellite. And you look and you say, yep, look at all this debris surrounding it. It blew up, and it's readily visible on this simplified map, let's say. Okay, another way of slicing and dicing it. Are there certain regions of space that are more vulnerable than others? And that's what this is trying to express. And what it's saying here is that the blue area on this world map is where United States space surveillance assets are concentrated. So one would assume that if you're going to do some attack against an adversary satellite from the United States, you would more or less do it within this zone. You're not going to do it way down here, south of Africa or whatever, where you have no assets, space surveillance, radars, optical, whatever, space fence. You have no assets to figure out where the target really is, to make sure you know where your weapon is, it really is, and to see the result. Excuse me, see the result afterwards. Now, if you wanted to attack, let's say, an adversary satellite, where are they concentrated at? Where are their space surveillance and so forth? And you can see sort of a concentration here over Russia and as far as their space surveillance assets. So if you want to do an attack on some potential adversary satellite, you want to make sure you're furthest away from their space detection zone, let's say. So it'll take the longest amount of time before they can figure out what happened, if nothing else. So this sort of implies vulnerabilities or optimal attack locations. The Chinese have a whole bunch of billion-dollar space surveillance ships with lasers going down the deck to see how much the ship is twisting and things like that. If you suddenly see a Chinese space surveillance ship in a part of the world, it might imply something happening, and these maps would warp based on that. Another way of slicing it, and that is, let's look at the minimal amount of delta V fuel it would take to attack you. If you had a target in here, it's hard to see. This is the red asterisk, and it's showing you the amount of delta V and by size of circle. The bigger the circle, the more fuel it would take. And the color is the amount of time it would take to match you. So the redder it is, the more of a threat. So this is giving you sort of a zone around your satellite where it's the minimal amount of delta V and minimal amount of time to potentially attack you. So you might want to concentrate your space surveillance assets, around here. And if you got some time, maybe go to the green, maybe the blue, deep blue. Suddenly it's like, yeah, that's really far away. It's going to take many days and a lot of W. It's probably not a threat. So again, it's a ways of just sort of thinking about this. And this kind of zooms in and showing you that this is the potential target. This is actually the gray boxes denote dead space objects who might be faking it out. I think some objects have been faking out being dead. The black boxes are live satellites. Um, so it's just another way of thinking about it. And none of these techniques are absolute. Space is so complicated, and we haven't really experienced major space wars. There's been about 10 minor space wars. So you're not really sure how things are going to come down. It's actually very easy to hide things in space. So you need many techniques, many ways of looking at it to increase the probability that you get it right. Now, here's a potential choke point, sun synchronous orbit. And this is showing you all these allied and military, non-military, adversary satellites, and so forth, and their altitude versus inclination, a very narrow band there. And look at these hundreds of objects. Now, any one of these objects can match the orbit of another one with only 300 feet of delta V fuel, very little. So if you wanted to attack an adversary's imagery satellites, let's say, they would be in one of these sun synchronous orbits, and you could build up a bunch of other satellites here, maybe over years or maybe over months, that maybe appear dead or they die supposedly and all that. And with probably a matter of hours, take out all the adversary space surveillance assets and maybe do it while it's over the poles or something like that. So there's no sensor seeing you doing it. And suddenly the satellite comes back, and maybe you didn't even create a debris cloud. You had some clever way of attacking it, and the satellite just stopped working. And you don't know how it happened, if it really was human caused, what was the intent, who did it. Tough thing to figure. Okay, now weaponeering. Now that's a concept for terrestrial forces, but it certainly is a concept for space too. And by weaponeering, we mean that there's what's called basic encyclopedia number, and it's like okay, this is the BE number of a target, an airfield, and that's the foundational B number, and then part of the B number is, oh, we want to go against this hangar in the on the airfield, and there's additional numbers that say we want to do the corner of the hangar, you know, and then the weaponeering is well, we need a GPU whatever glide bomb of this tonnage and this accuracy, and we need to adjust the timing so that it penetrates the concrete a bit and then explodes, or and then it looks like we need two A-10s and some sort of jamming aircraft for the anti-aircraft, and one A-10 is going to go in with this glide bomb and take it out, and maybe some sort of drone is going to look to see if the job was done. If not, the other one's going to, it's this whole process that you kind of try to figure out. And you even have, oh, we got plan A, plan B, just in case it doesn't work. So how does that apply to space? Okay, well, there's all ways to do this. There's all these sort of, and by ASAT is anti-satellite weapon. These are the sensor cones of various sensors on the ground that maybe you want to avoid. These are the timing values over date and time. When will you have view of these various assets? Here's a little bit more of the some of the space imagery satellites and what are their coverage cones coming over. And of course, it's all about orbital dynamics ultimately. So first of all, you have to optimize your objectives, and this tool's within SWAT, and there's actually a whole strategies task breakdown above this. And so we're right now down at the operational subtask, success criteria, and what are the indicators that you had success. So the operational subtask is intermediately jam command signals of resident space object, satellite A. And then what's the success criteria? Well, we measure the comm coming out. It's not working anymore. What's the indicator? Less than 10% of the traffic is still on. Some got through, something like that. And you got various purposes, concepts, what are the limitations, and so forth. And so this is an optimization tool that is telling you, okay, there's all kinds of ways to attack. So do you want to minimize the distance to the rendezvous with the target? You want to, how important is that to you on a scale from 1 to 10? But how important is it to you to minimize the time to get there? See, actually, there's only two ways to attack in general as a baseline condition. And that is, let's say you have a weapon in orbit. There's only certain parts of the orbit that you can actually start maneuvering to match the orbit of your target satellite. And so that implies certain choke points and things like that. But you can either start all of your anti-satellite attacks at the same time, but they'll reach their targets at different times. Or you can start all of your anti-satellite attacks at different times, so they all synchronize their attack at the same time for maximum, potential and shock and awe, so to speak. So this is the part of the planning process where you say, well, I want to minimize the distance to the rendezvous and minimize the time. I want to minimize the fuel usage. I want to maximize access to the Air Force Satellite Control Network. but minimize red surveillance access, on and on, things like minimize solar heating, make sure my satellite is pointed at the sun to get maximum charging. And, there's a lot of things that you could look at, like how accurate is the target element set, what's its vulnerability. And so you just put this together and come up with sort of a ranking scheme that'll be used later in optimizing courses of action. Okay, here's a weapon assignment. And again, there's theoretical weapons in here. This is a screen from SWAT, and you've got a what is euphemistically called a chaser for political correctness, but it's a space weapon. It's chasing the target. And you get to have these pull down lists tell you different information about it. And here's all the orbital information. And there's certain probability of kills, certain vulnerabilities, and so forth associated with the amount of delta V. And here's your potential target. Um, and you put these all together and you say, well, I want to start my attack at this time and then end it at this time, and it'll calculate the transit times, things like that. And you push the calculation button and it comes up with a list. After let's say you have 20 different ASATs against 10 different targets, it'll come up with a list that's rank ordered of all possible ways to attack it with all these possible weapons. And you look at that and choose, well, this thing uses less fuel, I'll choose this, but this one is quicker, I'll choose that one. And you click, and then you choose which ones you want to attack. And ultimately, then you do that with this sort of pop up. And you're saying is, well, I want a minimum of probably of kill, of permanent kill of 0.5, or of temporary kill of 0.52. I want to be the closest to the start time or end time within 2 hours. The cost exchange ratio. I want to make sure maybe this doesn't matter sometimes, but that I'm not using $100 million ASAT against a $10 million target. Maybe that's still worth it to you. What's the amount of delta V in transit time? And what are all the tracking telemetry control, the red, blue, and gray, trying to avoid, how is that all optimized for you? And so it does all those calculations within SWAT, and it comes up with optimization statistics, essentially. What's the total delta V fuel you're going to use? What's the transit time of all these attacks? Start time, end time, cost exchange ratio, visual brightness. How bright are you going to be so the adversary can see you coming? Are you going to be attacking with the sun behind the adversary and your sensors are going to burn out if you want to? There's all these little tactical things that are beginning to be expressed here. And I already showed you that one. And this is, again, another way of looking at this is sun synchronous orbit and all the various satellites within that orbit and the amount of delta V fuel it would take to match this one target here. In other words, showing you with the Holman transfer how easy it is to attack. Okay, and now what I'm saying is there's additional documents that if you contact me, that I can show you in all these, like the SOAD, space operational art and design, the doctrine, strategies, and tactics that was beginning to be illustrated in this SWAT tool. I didn't go over the all the other tools in there, for example, the wargaming tool and so forth. That'd be another briefing. So I'm part of a space warfare discussion group. You're welcome to join that if you want unclassified discussions. And if you have any more questions, because of the format of this briefing, they had to be written questions, and I'd have to be able to answer them later. So are there any other questions? Think about what you might do, and I'm going to stop this recording.